How do tasks actually work? So the way they work is that there is something called a task queue that is maintained, right? And every time you create a new task, right, you say hash pragma omp task, a new task is added to the queue, right? A queue is maintained and tasks keep on getting added to this queue. Whenever some thread finishes its existing task or has time to do some work, it basically picks up a task from this queue and executes it. So as and when the work gets created, the work keeps on getting added to the task queue, and as and when threads are available, they come and pick up the work from the task queue and execute that piece of code.
If we are not having a task, then also the fourth thread is going to spawn this block of a code.
If we don't say hash pragma omp task,
Yeah.
no, they're not going to spawn, they're just going to execute right here. So thread 0, the one which was computing some 0 to 99, it would have just executed this piece of code. So here you would have seen a print task computing some 0 to 99 from 0 of 4, not from 3 of 4, right?
But before that it could have run, that's what my doubt is, why it has not run that OMP task pragma one code.
So it's not in your control when that task is going to run. But what is happening here is that thread 0 has created a task, right? It has put it in the task queue. But thread 0 realizes that it has another iteration of the for loop to execute. It's not free. It's going to continue executing, doing its work. Maybe in the meanwhile, thread 3 has become free and it has picked up that work from the task queue.
So why we are saying that the very same thread 0 has to go back to execute the for loop for another iteration?
That depends on the scheduling mechanism, right? Remember there was a schedule clause, whether you're scheduling statically or dynamically, right? So here the default is schedule static. Okay, the default behavior when you don't specify the schedule is static. So what it has done is, it has pre-allocated these 6 iterations to the 4 threads. So the way it does it is, it divides 6 by 4, ceiling of 6 by 4 essentially, right? So that is what, 2. So it will give 2 iterations to all the threads, and to the last few threads it will just give 1 iteration. Just divided equally amongst the threads. That's what it's doing. So thread 0 has got 2 iterations to do. Right? If I had said dynamic, then it may have done something else, I don't know.
So once that's, I have hit the pragma OMP task by any thread, then it's going to be hit by another thread or?
So remember, there are multiple threads which are executing this code, right? Let's go through another example. So suppose that I have a linked list. I have to do some processing for each element of the linked list, all right? So how do I write code for this? An OpenMP code. I want to distribute that work amongst different threads. Let's say each node is storing a matrix and I want to compute the inverse of that matrix. So for each node I have to do a lot of work, but the work of each node is independent. The matrix stored at one node doesn't have anything to do with the matrix stored at another node, right? So how do I divide this work amongst OpenMP threads?
Either we compute one node at a time and go to the next node one by one, or we need to have the addresses of all the nodes.
Okay. So I need to kind of like maybe convert this linked list into an array first, right? Maybe store the pointers of each element of the linked list in an array, and then I can run a for loop and divide that amongst the OpenMP threads, right? That's one way of doing it. But using tasks, you can do it in a much simpler way. Okay, here is what you do. So you say hash pragma OMP parallel. What happens at this point in time? So 4 threads or whatever number of threads get launched, right? Now, inside this code, what I'm going to do is I'm going to say hash pragma OMP single. What does hash pragma OMP single do? Only one thread will execute this piece of code. Okay. So what is this piece of code now? I'll traverse the linked list. For ptr is equal to head, while ptr is not equal to null, ptr equal to ptr next. So I'm making a lot of assumptions over here, right? I have not defined the data structure for you, but I'm assuming that you've all worked with linked lists, so this should not be any surprise, right? Okay, so now you start with head. So what is head? Head is, let's say, something defined over here, right? Struct node star head. That's the head of the linked list, right? So what do I say for pointer is equal to head, while pointer is not null, pointer equal to pointer next. That's my for loop. What do I do inside the for loop? I create a task. Okay, I say hash pragma OMP task. I can give a structured block, or if there is only one statement, then I don't even need to put a parenthesis, right? I can do without parenthesis. So in this case, I'll just say compute inverse, and I pass PTR matrix. Maybe matrix is the pointer to the data. So what's going to happen now? When I hit hash pragma OMP parallel, at that time 4 threads are spawned, right? I mean, I'm assuming OMP num threads is 4, so 3 more threads are spawned. Total you have 4 threads. Now one of the threads goes inside the hash pragma OMP single and traverses the entire linked list. Okay, and for every element in the linked list, it creates a task. And what are the other 3 threads doing? They are doing nothing. So they are going to start picking up the tasks and start executing. Okay, and once this thread, let's say thread number 1 is executing this, once this thread finishes execution of this for loop, it's also going to join them and start picking up the tasks and doing the tasks. It's an extremely convenient way of creating work. So it saves you a lot of trouble at times in trying to yourself figure out what is the work to be done by what thread, how am I supposed to divide it up, right? It frees you from all that trouble. Whenever you find some piece of work, go create a task. Of course, there are some challenges that if there are dependencies, then you have to be very, very careful, right? Because you have no idea how these tasks are going to get executed. You cannot even say that the task that is created first is going to get executed first. No. Is it going to start first? Is it going to finish first? Nothing at all. All these tasks are independent pieces of code that will get executed at some point in time. You have no idea when they'll get executed. So you have to be careful where you introduce the task, right? You have to be sure that these are independent pieces of code.
Nothing for the other threads to do, then only it's advantageous. Then only we use it. Here we're using open thread pragma OMP single.
Yeah, but that's not the way I did this previous one, right? What did I do here? What is the difference between this array creating tasks in this summation of array and the creation of tasks in that linked list? What is the difference between the two? So there only one thread was creating the work, creating the tasks. Here multiple threads are creating the tasks. So it doesn't matter, right? It's just that a lot of times we find that it's convenient, like in case of a linked list, multiple threads can't even create the work, right? Because you have to sequentially traverse the linked list. There's no other option. Okay? But in case of an array, I had that flexibility that I can have multiple threads create the work. So I employed multiple threads to create the work. So don't get stuck on, whether I'm supposed to create it from one thread or multiple threads. Either ways is fine. Any thread at any point of time can create work, can create a task. Doesn't matter. And any thread could end up executing that task. Okay?
Like here too we are putting the limit of start and end start and end is the size of an array which is defined by the thread only. But if the task is common, will it get respawned?
No, what do you mean by task is common?
Like
there is nothing like a common task. Look, the important point here is these tasks are not the same because each one of them is working on a different piece, right? Yeah. If they were working on the same piece, they will be like 2 different tasks that are doing the same work, but there will be 2 instances of that task.
There will be
2 instances of the task. Right? If thread 0 and thread 1, both of them decide to compute the sum over the same part, OpenMP or the runtime is not going to figure out for you that you are doing something like that. For them, it's just a task. One important point is that you have to understand that you can only create tasks inside the parallel region, right? There is no point of creating tasks outside the parallel region. There have to be multiple threads executing for you to create tasks.
So I can't do something like I have a lot of work, let me just create task and then start a parallel region.
No, that's not the way it works, right? You start a parallel region, you have multiple threads, and then you start creating the tasks.
So it will probably be doing similar stuff. If I want to do say 3 or 4 different things, and each of them have their own parallel stuff, then tasks is not the way to go.
No, that's not necessary. I could write anything inside the code, right?
Right, but there's only one piece of task code.
Yeah, but that is a code, and code I can write anything in a code.
Okay.
So in that sense, I could ask them to do different things. Doesn't matter. One thread could be computing a factorial, another could be computing the inverse of a matrix. It's up to me. I can write the code. It's just that typically that's not what you do, right? Typically you have some similar stuff going on.